today will be a very exciting day for us. We are starting our unit on representing the solution to a system of inequalities.
No! Oh no! But Mr. Dotted Line, I've heard that people always do horribly on this test. I don't want to fail. This will end my entire middle school experience. Then I won't be valedictorian and then my life will be over.
No, students. I remember taking this course and it really wasn't that bad.
Oh no, another 37 on my representing the solution to inequalities test. My mom is going to ground me for life. I have to do extremely well on this retake. I must attend these sessions. Hopefully they will end my failing streak on these tests. Hello, I'm here for my tutoring session.
Yes, we've been expecting you.
Well, why don't we get started with turning that 37 into 100?
So you have been having trouble representing the solution to a system of inequalities. Well, here at No Boundary Line Can Stop Us Math Center, we can certainly help you.
Well, why don't we start with a couple of basic facts about systems of linear inequalities. You might want to write these down. A system of linear inequalities consists of two or more linear inequalities with the same variable. A good way to tell if a pair of inequalities are a system is to see if a certain coordinate is a solution for both inequalities. The region on the graph that is the intersection of two or more inequalities is known as the solution region. Lastly, it's a quick helpful tip to know about graphing a system of linear inequalities is to always shade each inequality line in a different color so that it is easier to see what the solution region is. Mr. Doggerline, we will go over these later.
Okay, so first of all, when we have systems of linear inequalities, we need to graph them to represent the solutions. However, to be able to graph them, we need to make them be in a linear format, y equals mx plus b, where m represents the slope and b represents the y-intercept. So we need to isolate the y. For example, let's take the system 4x plus 2y is greater than or equal to 6, and 24x plus 4y is greater than or equal to 16. These are not in a linear format, so I will show you how to do this. We will subtract 4x and 24x from both sides, and after that, we will divide by 2 and 4 to isolate the y, which would leave us with y is greater than or equal to 3 minus 2x, and y is greater than or equal to 4 minus 6x. So now we have our linear format. Alright, so now that we have everything in the linear format, it's time to change the inequality signs to equal to signs. This is not permanent, but it is easier to graph the inequality if you think of the inequality signs as equal to signs.
Okay, now we are going to graph the system of inequalities to find the solution region. Remember that word from our learning goal notes? Well, it's about to become extremely important. Okay, so now it's just to graph the two inequalities as if they were regular linear lines. But write the inequality of the lines on the lines. So far, so good? Now realize the fact that these are actual inequalities and these lines that we have drawn are actually called boundary lines.
Boundary lines inform us the boundary to which we can color/shade to above or below the line. Now these boundary lines will be dotted if the inequality signs are just less than or greater than because they don't equal the numbers that the boundary line runs through. If the signs are less than or equal to and greater than or equal to, then the boundary line will be solid because they equal the numbers that the line runs through. Pop quiz, what type of line will we have for our inequalities?
A solid line because both of the signs are greater than or equal to.
Good job. Okay, now for the shading. Since these are inequalities, just the boundary line is not just the solution. We have to shade accordingly to the signs. If the inequality signs is y is greater than or y is greater than or equal to something, you are going to shade above the line. And in this case, you are going to do that. But if the inequality sign was y is less than or y is less than or equal to something, you would shade below the boundary line.
Okay, now do you see this area where both of the colors intersect? I have highlighted it in pink. This is known as the solution region. Any coordinate set in this region will satisfy both of these equations in this system. And a couple examples of some solutions are the coordinates 8, -6, and 14, 2 because they're inside the solution region where the colors intersect.
I actually understand this, yay. However, I do have one question. What if there are 3 inequalities?
Well, if there are 3 inequalities in the system, you simply graph and shade areas for all of them, and the place where the 3 colors for their shaded area intersects is the solution region. Why don't you try this problem for practice?
Okay, so the first step is to make these inequalities into linear formulas. But since they are already linear, I will proceed to make the inequality signs into equal signs so that they are easier to graph. I graphed all of these equations to get the answer down here, and how I did that was they looked and saw the greater than or less than signs to know where to shade it, and this was the only places that each one was shaded for. Thank you so much. I'm sure I'll do much better on the retake.
And that's how you represent the solution to a system of inequalities. One more thing. Notice how the shaded areas of the graph never intersect. That means there's no solution. To elaborate, there are no coordinates that will make both inequalities true.
Thank you, Mr. Dotted Line. You explained it so well. I may actually do really good on this test after all.